Watch Mr. Wizard. That's what all the kids in the neighborhood call him because he shows them the magic and the mystery of science in everyday living.
Mr. Wizard!
Oh, hi, Rita. Come on in.
Hi, Mr. Wizard.
Hi. Come on here. I have someone I'd like you to meet. You know her?
Yes, that's me.
It is? The headless
No.
girl?
I have two heads then.
In fact, here, why don't you do it this way? Now you're a girl without face. Now you're a girl who...
I'm gone.
You're gone. Now, let's see. Now, get this way. This is what I want you to do. Turn around this way. Like this. There. Now, oh, you're touching nose. You're two girls stuck together by the nose. Here's another one. You stand like that. Now, bend your head. The other way. Sideways. Sideways, this way. Because I want to put my head on top of yours, so with my head on your shoulders. There. How's that? How come we can do all these silly things?
Oh, well, this isn't an ordinary mirror.
It isn't?
It's a curved mirror.
Oh.
Yes, it goes out.
In
and
fact,
then
watch this. See that?
the finger's suspended in air.
That's a finger suspended in air. Not only is it suspended in air, but there comes the mother.
Spider. Yeah,
Oh, here's Spider.
Yes.
See that? In fact, see, I can make my hand or fingers disappear like, there's the whole hand coming in and out. In fact, here's a colander, you know, the kind that you sift things through and stuff. Watch, a big thing like that I can not only make disappear, but I can make it look into all kinds.
So there it goes, big, small.
See, now there's just the handle. Now watch. By bending it in certain ways, I can close the top. Looks like a big fish.
Yes, doesn't it?
Yes.
And it's awfully small before.
Well, now, why is it, look, you can make something real big this way. You can also make it get smaller and smaller and smaller and smaller and smaller and finally disappear altogether and see a funny-looking girl like that. Why? Just because a mirror is curved, what should that have to do with it?
Well, I don't know. Why should it be? I know it's curved.
You look so ridiculous, I don't even want to talk to you. Well, not only, have you got a mirror like this around the house?
No.
You don't?
No, this is
well,
a funhouse mirror.
let's see if we can find some mirrors that are ordinary mirrors that are around the house that do some of the same things as this funny-looking mirror, and maybe then you'll be able to understand a little more about how such mirrors as this work.
All right.
Here's a mirror. Have you got a spoon around the house?
Oh, yes.
Well, if you get a nice chromium-plated spoon so that it's nice and shiny, and you look in it the right way, you can see yourself, and you'll look something like you do in that funny mirror, don't you? Now, what do you look like there?
Well, I don't know what I look like.
Well,
like thin.
you look
Yes.
small,
Yes,
right?
smaller.
And notice, oh, what a great portrait this is. You don't look terrible. Anyway, when you look at the rounded side of the spoon, the back side, why you look small.
Yes.
And right side up, huh? Well, now I'm going to turn it around. What happens?
I'm upside down.
Yeah, there you are, upside down.
Ah, the blood
And
gushing to
small,
my head.
and small too, right?
Yes.
Well, now how come? Here is a fun mirror that you have right at home, and with it, you can see that two very different things happen. In one case, you're upside down. In the other case, you're right side up. How come?
I don't know why. How come?
Well, that's what we're going to find out. If you don't have a spoon, why, you can take a shiny tin can. That works pretty well, although it isn't quite as good. If you see, you can't see yourself quite as good. But see there,
Yes,
you can see.
I'm
You can.
small there.
The closer you get, why, the better it is.
I have one eye.
And notice if you have the can going up and down this way, you're tall and skinny. If you have it go this way, you're fat.
Fat.
And if you turn it around on the inside, you have to get way in before you see yourself. So there's our problem. We're going to see if we can somehow figure out why it is that not only can you make things smaller or larger, upside down, and also, in the case of that fun mirror over there, completely disappear.
Well.
You remember that story, Alice in Wonderland?
Oh, yes.
And whenever she went
through
through
the
the
mirror.
looking glass, that's what we're going to do. Come on over. Let's start and see if we can go through the looking glass and create things on the other side that aren't there. I have a chair there for you. Would you please sit down? And here is a plain, ordinary, flat mirror, right?
Yes.
Okay. If I put it here, I have two little nails here on this board, so I have it touching the nails. What do you see?
Oh, I see the block inside the mirror.
What block?
This block.
Where do you see it?
It's in there, way back there.
Where?
Right around there. But
I don't see
it's
any
not
block.
there now, but in the mirror it's there.
Oh, now wait a minute. Where is it?
It's just about over there.
I'll take another block and put it down over here. Is that where it is?
Yes, around there.
Is that the right way? Is it facing the right way and everything?
Uh-huh.
It's about there.
Yes.
Well, in other words, what we have to do is somehow get the light that's reflected from this block to go into that mirror and create a mirror there on the other side that isn't even there.
How can we do that?
Well, scientists puzzled about that for a long time, and they finally had a rather intriguing way to figure it out. What we have to do is somehow get the light to create a mirror over there. All right, let's do something. Let us take a little point of light right there. Light is reflecting onto this thing, isn't it?
Yes.
And it's going into the mirror, hitting all over the mirror here. Some of it is reflected back over here to your eye, and that's
That's my
squiggly,
eye?
that's your eye there, yes. Let us take a thread and attach it to this point over here and assume that we are going to trace the path of one light ray over to your eye. Now, how do we know that it hits your eye? What happens to this light ray when it hits there?
When it hits the mirror, it bounces back and goes to my eye, and then I see the image.
Well, how do you know that it hits your eye, though? What happens when the light hits here? What angle does it come back?
Well, angle of incidence equal the angle of refraction.
That means it refraction. That means if we
Yeah.
draw a line perpendicular to the mirror, this angle would have to
Should
equal
equal
that
that,
angle.
yes.
Well, we don't want to measure it this way. How can we show that that actually is true?
Well, this line is
Yes.
already in the mirror.
Yes.
You can see it in there. So all I have to do is make it straight.
Line this
Yes.
up with that line. Is it straight?
Yes, just about, I think.
Okay. Now, your eye then receives this little bundle of light that's coming down this this line right here. But you're seeing the thing way back here someplace.
Yes.
In other words,
Yeah,
the
but it's all
point
way
from the
down there.
high end of it here has to lie somewhere along that line, according to your eye. So it's back here someplace. Well, let's do this. If I take another string and trace what is happening to that line of light right here, it's going to lie somewhere along a line that's right even with that, isn't it? You want to pull that tight?
Right.
Someplace along right there, isn't it?
Yes.
Notice I'll put the block right there, and that's the line of light that's coming from there. But the eye instead thinks it's out here. Get the idea?
Yes. Like in the mirror, that's where I'm seeing it, back there.
But that's only one little line of light that's coming, one little sort of bundle or beam of light. Let's take another beam that comes from the same point. It's reflected over here or over here or over here. Let's choose a point right where I have that other nail, because that would be very convenient in view of the fact
Yes.
that I already have the nail there. Now, we've already traced this one with that. Now you have to get this line of light, this line that bounces off the mirror, to coincide with that one back in the mirror. So would you line this one up with that?
It was just about straight then.
Okay.
It's right there.
In other words, the second little beam of light's coming out and going up like this, and your eye says, well, that point that I see must be down along this line.
Yes, so
Well,
you have to keep on going back and
let's
see
trace that one
where
out.
it is.
If I take this thread and put it over here like this, now I can get that first one. Here was the first one we lined up, right? Now watch what happens to the second.
Well, they cross each other.
Yeah, and they cross each other right where I had that thing. So you see what we've done? We've got a point here that's been reflected from the mirror and off to your eye, and your eye says that point must be right there
So that's where I see it.
on
in
the other side of the mirror, yes. Let's do the same thing now for another point over on this side. And I think you get the idea now. Don't you?
Yes.
If I put this up here, can you line up those two lines of light? Line this one up with the image of that,
And this one with that.
and this one with the image of that. You got this one, and this one together, and that one and that one. Okay?
Right there.
Now, if I take the mirror away, because after all, the image is behind the mirror, isn't it?
Yes.
Would you pick up that little, can you pick up this little triangle?
Okay.
Because I want to move it over here. See where those two cross? Someplace in about like that.
Yes.
That would be the high end, or the low end here, right? See? We would set it right like that. Now, unless our angles were very off, have we created a triangle back there?
Yes.
See it? Roughly right there. Because you
The same
see,
place as I see
well,
the mirror.
really what happens is if you take another line of light from the center of this block and trace it out, why, it'll end up back in the center over here. In fact, all the light reflected from this block is reflected into the mirror, and it comes back, and all those of it that hits your eye come back here and form that image back over here.
Yes, I see.
Now, is there such a block back here?
The block is there, but we
No,
can't see
no,
it,
it
though,
isn't.
unless it's in
It's
the mirror.
not there.
It's really in the mirror.
That's right. It's an image in the mirror of the light that's reflected from the mirror. So what do we see when we see with a plane mirror? What kind of an image do we see back there? Bigger,
see
smaller?
Well, it's the same size.
Same size.
But it's reversed.
It's reversed. And it's back in there someplace.
Yes, it's all back.
Okay, now let's go look at a regular mirror, such as you might have on your wall, and see if that's true with you, too. See that?
Yes, that's an ordinary mirror.
Plain, ordinary, flat mirror. Now you go around and look in there and see, do you see yourself?
Yes.
Same size?
It's an image, yes.
Yeah, but what's this up here? This is on your right side.
Yes.
In real life, what side is it on in
It's
there?
on the left side.
It's on the
It's
left side,
reversed.
so you're reversed. And you're the same size.
Yes.
Okay. Now, what's going to happen if we curve the mirror? Why should making the mirror curved ruin the whole image? That's the next problem.
Well, why should it?
Well, let's
better.
take the simplest one first. You sit down. Somehow, when we bend this mirror, it has to do something to these lines, doesn't it? And we have to create an image that isn't there, not only isn't there, but never existed in any place, anywhere, anytime. Let's try this one.
Well, that's convex because it's
Curved
curved
out.
out.
All right, let's put that there. And now you understand what we're doing with these lines now.
Yes, we're
You
making
trace
them straight.
Yes, you trace what happens to two little bundles of light that come out from the low side here and go up here and hit these 2 points. And you trace what happens to them out there.
And this
You
line-
tell me what happens to this one right here.
Well, that one in the mirror is
Bounces
sort of,
and comes out
yes.
there? Okay. What happens to this one?
It bounces and comes out here.
Okay, is that lined up?
I think just about. But in the mirror, it's sort of curved. It's not exactly straight.
Well, I think that's maybe because my mirror is kind of curved out there. Now, when these 2 points of light come out and go back there, what kind of an image do you see in the back there?
I see a smaller image.
Smaller.
Yes.
Yes.
It looks smaller.
But is it reversed?
Yes, it's still
Okay.
reversed.
Let's see what happens to those 2 lines when we go back there. Now, I'll line up one with one and one with the other, just like that. In other words, your eye says that someplace along these 2 lines, there is a point of a triangle that's right there. Sort of like that. Right? Okay, let's try the other end. Where should it come?
But you could come around there.
It should come over
because-
there, shouldn't it?
Yes.
So if you move these, which way is it going to go? Should it go
You have
that
to
way
do
or this way?
This way. Of course, the lines
No,
has to be
no,
over
go the
here.
other way. Well, you'll see. Try it. If you put this up here, and you're now going to reflect from this side, which way should those lines? You match that one
This
with
one?
that. Yeah.
Go here.
That one with that one.
And this one
And
would.
then that one with that one.
Do I have my lines straight?
I don't know.
The right lines with the right ones. I'm getting mixed up.
Which way should this go now? According to you? Like that, huh? This should be about like that. Well, let's check it. You look in the mirror.
Yes, there it is. Now let's see. It's pretty good.
Pretty close?
Yes.
So we have created a triangle that doesn't exist, and it's smaller, and closer. It's really further away, but the image forms closer. And what happens now when the mirror is curved out? What kind of conclusions can you
We
come
have a
to?
smaller image.
Smaller,
And it's
reversed
still
image.
reversed.
Okay. Now let's go see if that happens with you too. New mirror this time. Take a look at that one.
That's convex because it's curved out.
Curved out. Okay. What happens to you in that?
And it's smaller.
Now, you're smaller than before. So am I. You can get both of us.
Yes.
Can't you? Yeah. And does it make any difference how close you get? You're still smaller than
I'm
life
still small.
than life size, right? Okay. Now, and the reason for this is the curved mirror bends the light in such a way as to create this image back there, smaller than in real life. Now, where does it make any difference? Look how far you can go, and you still
So it still looks small.
still look small. You can see all parts of the room back here too, can't you?
Yes.
Where do they use such a mirror for some practical use? Why would you want such a mirror?
Well, you'd want it for some reason to get a lot of, images in there.
Okay, can you think think of any examples of such a mirror around the house?
I know, I can't think
Reach
of
out your right hand. You'll probably touch it. Yes, the spoon.
Oh, it's curved.
Yes,
Oh,
you see?
oh, yes.
That's now, you should be able to explain to me why it is that when you have a nice shiny spoon curved out and you look into it, what do you see?
A smaller image.
You see a smaller image than you, right? All right. Every time, and now, if it's curved real sharply, would the image be bigger or smaller, would you guess?
Smaller.
Yeah, the more it's curved, the smaller it would get. So therefore, if I turn it this way, you're going to be small from top to
Yes.
bottom. Right? If I
Yes.
turn it this way, you're going to be smaller
Thin.
from,
Yes,
thin,
nice and
sideways. Okay. Now, how about this tin can? Wasn't that the same thing?
Yes.
Okay.
Nice
you,
and thin.
And you should look
The other
nice
way
and thin, and that
I'm
way you
real
should look
bad.
nice and thick. Okay. Now, the same thing is going to be true on the fun mirror over there. But how about in everyday life? Where, these aren't really very practical. You don't have a spoon to look at. You need a spoon to eat. Where do you use a mirror that is curved out?
Well, where? Oh, a rear view mirror.
A rear view mirror in a
Yes,
car.
because you want to
that's
see
right.
all the cars around you.
Yes, you want to see all the
Yes.
cars. And in this case, this is what I call my special beautifying mirror. Watch closely. Isn't she a beauty? Oh, say, amazing. You should have one of these in your bedroom. I'm sure that you'd start off the day right with one of these. Now, why should this be a good rear view mirror?
Well, because of its shape, you could see a lot of images around all the way around the place.
But one of the problems is that while it is true that you can see many things behind you with it, it also makes things look further away than they really are.
Yes, they'll be smaller.
So when you
Yes,
have
it's
one of
nice.
these rearview mirrors and you look at it and you're going to turn, out to go behind traffic, well, you better be sure that you realize that that car that you see in the mirror behind you is closer than you think.
Yes, because it's smaller.
Okay, anyway, here's then is how you use such a curved out mirror. And when we look at the fun mirror before, whenever we see a small, skinny image, and it's right side up, it means that the mirror is curving out.
Convex.
Okay.
All right.
Let's try the other kind now, because this gets very tricky. Look out now. I'll warn you. Okay, what happens?
That's way off.
What happens?
All the lines are all crooked.
All right, they're all crooked.
The image in there is bigger.
And the image is what?
It's bigger.
Is it reversed?
Yes, it's still reversed.
Reversed and bigger. Now don't forget we're working with just a plain mirror, slightly bent, not a spherical one, so there's a difference. Let's trace what happens to this line now. It comes out and bounces off, and is it going in the right way now?
Yes, it should be balanced off this way.
Yeah? This one? How about that one? This one should be, this should be
Yes,
with
I
that,
see.
okay?
Here.
How about that one should go with this one?
That
Because
one.
the light is now going into the mirror and bouncing off, and angle of incidence still equals angle of reflection.
There.
There?
I think it's there. Yeah.
Now what's going to happen if we trace these things back behind the mirror? That's no good anymore, is it?
No, this is a different mirror now.
Look what's
Okay.
happening.
It's all the way back there.
Yes, it's way back here, about like that. In other words, see, that's the high side, something like that, huh?
Yes, it should be back there.
Now we're going to look at the small side. If that is correct back there, which way should they go?
Well, it should be on the right side because that's where the smaller side is.
Okay, try it.
Yeah.
This one,
This
and that
one.
one,
There.
and this one,
This one.
and that one.
And there.
All set? You said it should go which way?
It should go to
Look
to
like
my
it's going
right.
there?
Yes, it does.
I'll put this one up here like that. It looks like it's going to end up right pretty close, huh? It's on the right side, but I'm in the way. Something like that. Okay, what kind of conclusions do you come to now that when you have a mirror that's curved in, concave, is it about right?
The
Check.
image is
Check. Is
larger.
it about there?
Yes.
About there?
It is.
Yeah. All right. Remember, there isn't any such amount like here now.
No, there
You're
really
only
isn't
seeing an
there.
image,
It's
and what does
just
it
in
look
the
like?
mirror. It's much larger than the real image.
Yes, and
And it's reversed. It's
and
still reversed.
Does this happen with a real curved mirror now up there when you look at yourself?
Hey, let's see.
Careful now. Careful. How about that one? Is that the right kind?
And that's concave, all right.
See, it goes in this way, mirror on that side. All right, check yourself now.
I can't hardly see it. Where am I?
Yeah. What? Try backing up one.
Yeah, I'm upside down.
And are you bigger?
No, I'm smaller.
Well, what's going on here? I thought you just got through diagramming it and see that you should be bigger.
But I should.
Back
'cause
up
we
further,
even
yeah.
diagrammed it.
You're getting smaller. Come back. Come back. Oh, good night. Get real close.
I'm big.
Yes.
Now it's wrong.
Now it's wrong.
Is
Well,
it
it's now you're
bigger?
correct, aren't you? In other words,
Yes.
this is the way you diagrammed it over there, and you saw that you were big. But notice what happens. As you move back now,
I disappeared.
Pretty soon there's a place where you don't see anything. And then
Where'd
if you
I go?
Then if you go back further yet, what happens?
Now I'm upside down.
Yeah, you're upside down and smaller.
Yes.
Now, how are we going to solve that one? You were right, but only part of the time.
Now why did I turn upside down?
Yes.
And why did I disappear?
Okay. Let's see if we can figure out what happens, because it's not quite as simple as those little lines seem to indicate. Let's look at this in a different way once. Let's take this string and put it over here. All right, we should put it about where parallel light is, about like that. Let's assume that a pair of parallel beams are coming in here. Those beams, would you line it up over there? This one is supposed to go with that one, so trace it out.
Now which one?
This one is supposed to go with that one.
Mm-hmm.
Yes.
Yes.
And this one is supposed to go with that one.
There.
Now let me try it over here once and see what happens. Now try that one. They're going together over here instead of going
Yes.
apart, aren't they? Try. Is that pretty close?
Mm-hmm.
They cross.
Why did they cross?
Well, let me see if I can explain. When light comes into a mirror like this one, especially parallel, and this isn't quite parallel, but when parallel light comes into a curved mirror like this, you know how you've seen it sometimes if you use light, it gets and focuses at a point?
Yes.
This is how you can use a mirror to start a fire and things like that?
Mm-hmm.
Well, that's called the focal point of the mirror. And as long, and this could represent the focal point. It isn't quite, but it could represent it.
All right.
When you look at an object in a mirror like this, at this point, you can see how the lines go out this way, and it would look like it was a large
Yes.
image. So if you look at it inside the focal point, it's going to be a large image. If you look at it right here, are you going to see anything?
I don't think you should say anything.
These
Of
two,
course they cross.
these 2 points now come, and they are joined, and you won't see a thing.
Oh, that explains why I
That's
disappeared.
why it disappeared. When you come out here and look at something, now it's going to look smaller, isn't it? You see how these beams go together? The lights go together, and so that when you see something, it's going to be smaller. Here's the low side of the triangle. Let's watch what happens to it. Low side comes along here, goes over here, and if you look at it here, it's going to be reversed, isn't it?
Yes.
The low side.
Yes, low side.
Look what happens to the low side.
It crosses.
Yes,
Now
so
it
it-
should be on the upside down.
So you'll be upside
Oh.
down. That's the idea. So when you see this kind of a mirror, curved in, and you look at something closer than the focal point, most of the time you're going to see a large image right side up. At the focal point,
You
what?
won't see anything.
And when you get beyond the focal point?
It should be upside down and smaller.
All right, now let's go back. See if you can tell me where the focal point is.
Okay.
Now, get in real close.
Now, this
Obviously
is
you're
round
within the
big,
focal
yes.
point, right? Because you're very big. Now start moving back.
Now, here must be the point where I disappear, so
Yeah.
this is where they cross.
Someplace in here, well,
Yes.
it's actually in this kind of a mirror, the focal point is not at one point, but it's a whole series because the image gets very, very messed up and you can't hardly see anything at all. Okay, then go beyond that.
Now I'm upside down.
Now you're upside down
Yes, and smaller.
and smaller. Okay, so it does work, doesn't it?
It sure does.
Now, in spite of the fact that you go back further and further and further, you see?
I'm still
You
upside
have-
down.
Still upside down. There I are, both of us upside down. Now, just one word about that focal point, that if you had a sphere, a big ball made the size of this, there would be a center here, wouldn't it?
Yes.
Well, the focal point is halfway between that center point and the mirror, so it would be someplace in here. And that's where you
Oh.
stand, and so you disappear. Now, where do you use this around the house? You don't have one like this, do you?
No, I
Well,
don't
come on over
have
here and
one
let's
like
look. Let's look at those everyday examples that we had. We saw the spoon was a outside.
Convex.
All you have to do is turn it around.
Oh, and then it's concave.
Sure, then it's concave. And what do you see?
I'm upside down, all right.
You're sure upside
Yeah.
down, aren't you? Now, what happens when you get
Yeah.
closer? I'll see. Where will you disappear?
Just when the 2 points meet.
The focal
Yeah,
point.
well-
Someplace in there. Can you see yourself?
No, I feel like I'm close.
Now, how about your nose? You can see your nose real big now, or your eye? Because you see, this is curved quite a bit, so the focal point's way in there, so you have to get very close. But when you get back, then you're upside down. All right. So here is a good example of a nice mirrors, both kinds,
Convex and
convex
concave.
and concave. So that's why it flips upside down in one case and stays right side up in the other. How about this?
Oh,
This was
yeah.
the
Yes.
curved out, if you turn a can around and there's a nice shiny can inside, you can see yourself again.
Yes.
Just not as clearly this time, but now you're. I can't get in close enough to get to the focal point. But notice that this is not a sphere like the spoon. This is like sort of a ball. This is a cylinder. So it depends on which way you turn it, what effects you're going to get. Now you're upside down, right?
Upside down.
Now you're upside down. Okay. And how about around the house? Where do you use such a mirror?
Well, I don't use it as shaving.
You don't use it, but you later on you may put makeup on. And here is a makeup mirror that is very, very slightly curved. And as you can see, when you're clothed, you get big. And as I move back, what happens to you? You get all fuzzy and you disappear. And now finally, when I get back far enough, what happens to you?
I turn upside down.
You're upside down and clear again. So there's a good example of it. Now let's look at that funhouse mirror that you have that we had over here and see if you can tell me, as we look at various parts of it, how the curve of the mirror goes by just looking at it. What happens to you? Okay. Now let's see. Let's start. All right. Well, let's start like that, right there. See that girl? What kind of a surface is she being reflected from?
Well, I'm big.
You're tall, but you're skinny this way. So where does the curve go, in or out?
That would be convex. It would
Goes
be
out this way. That's right. The mirror curves out in order to make you tall and skinny. Now what happens over this girl right there? That one.
Two girls.
That big fat one there.
Well, that would be concave.
Yeah, right, you're concave.
in.
Obviously,
That's
the
why
mirror
I'm
must
bigger.
go this way then, doesn't it? It curves in here because pretty soon you're going to be at a focal point out here. And what happens when you get at the focal point?
I should disappear.
And there you go. You're gone.
Goodness.
So am I. So now, by just looking at this such a funhouse mirror, you can see exactly how it's curving. Watch, I'll put my finger in now, and you won't see it, and suddenly it'll appear out of nowhere.
Oh.
And that's what, because the curve is hiding the rest of my hand. The finger looks like it's out in midair. Here are all five of them. Look like five
That's
hot
just
dogs.
scary, isn't it?
Isn't it? Oh, it's. And of course, even such a large item as this colony you can make disappear because it goes behind that curve. There's the handle. There's the little one.
It's
I'll turn it
bigger
around
and
so I
smaller.
turn it around so I can get a fish. Let's see, where was the fish? There it is.
There it is.
Yeah. So you may not have a mirror like this around the house at the moment, but if you can get a plastic mirror, bend it with a couple of curves like this, and you can make a lot of things disappear and at the same time learn what happens with curved mirrors.
Watch Mr. Wizard is presented each week at this time by the Public Affairs Department of NBC News in cooperation with New York University.